Our objective today is to be able to graph a little bit more challenging sine and cosine functions. This is the most important lesson of the unit. Y is equal to, say, -2 sine of 4x minus pi over 2 plus 1. We want to make sure that by the end of the day, we can graph that and not feel like it's a big deal. Okay? But in order to do that, we're going to have to really focus and pay close attention. Those are going to mess up. So let's start with what we already know. If I have a function now of this form, before we talked about A and B and how they affect the sine and cosine graphs, does anybody remember how we determine the amplitude? Very good. The absolute value of A. The amplitude determines how high we go or how low we go. The period, what is our formula for the period? 2 pi divided by B. Does anybody want to guess what happens with that thing? If we want to guess what happens when we add something to the end of the function. It goes up or down. So the vertical shift is just D. So that's all that number does. So now you've seen what A and B and D do. In order to figure out the horizontal shift, what's that? We have to solve Bx minus C is equal to 0 in order to determine the horizontal shift. You can't just look at C. You have to solve that equal to 0. When we go about the process of making these graphs, this is the order that I encourage people to do it. If you've got a different idea, then you go ahead and you do you, okay? But I think that this is the best way to teach people. So I'm going to start with example B. I'm going to start with example B. And the first thing I'm going to do is identify the vertical shift. What is the vertical shift of this graph? 2. So I'm going to write vertical shift as 2. And what I do is I take the entire graph and shift it up 2 units. So that means instead of being centered on the x-axis, it's shifted up 2 units. So I'm going to move it up 2, and I'm actually going to draw kind of an imaginary axis here that it kind of rotates on. So my vertical shift, I draw the imaginary axis. Have I lost anybody yet? Okay, now we go to the amplitude. What is the amplitude of that graph? 3. This is where people start to get confused. If I'm at 2 and I have an amplitude of 3, how high will I end up going? 5. All right, here we go. So, Tanner, you said 3, right? And you're right, that's the amplitude. But if I start here, you see it's going to go up to 5. From here, it goes up 3 units. 1, 2, 3. So it goes all the way up to 5. And then again, if it's centered at 2 and the amplitude is 3, it's going to go down to -1. So we get to the amplitude, mark the max and min. See that? So that's the vertical structure of our graph. Now we go to the horizontal structure of our graph. Period, you take 2 pi and divide it by b. What is the period? What's the b value? 2 pi, because you're dividing by 1. 1 is the number in front of x. Very good. Greta says 2 pi. She's correct. So I take 2 pi and I divide it up into 4 parts. 2 pi divided in half is pi. If I divide that in half, I get pi over 2. And then if I multiply that by 3 pi over 2. So we do the period again by 2 pi divided by e. At this point, you're always going to make a graph. You're not going to worry about the horizontal shift yet, okay? And I'll teach you why in a second. This graph here does not have a horizontal shift. Only if you see parentheses like this is it going to have a horizontal shift. If you take the inside and set it equal to 0 for your horizontal shift, you get x is 0. That means that there is no horizontal shift. So we have to worry about that. So we're just going to sketch our graph. You are ready to sketch the graph. All right, cosine. Where does it start? Max, min, or middle? The maximum. Cosine starts either at the maximum or minimum. If it's positive, it starts at the maximum. If it is negative, it starts at the minimum. So where am I going to start for my cosine graph? All the way up here at 5. If I'm at the top, I have nowhere to go but down. So I got to cross over this middle spot here. Have I reached the bottom yet? Nope. So as you go over one more spot, you get to the bottom. I'm at the bottom, nowhere to go but up. Now you get to the top. Notice if we continue that same kind of pattern on the other side, notice what we get. I could draw my graph. You can see that this is the same thing as we did Tuesday. The difference is instead of the graph being centered on the x-axis, everything is shifted up exactly 2 units. Okay, we got 2 more left, or 3 more left. Vertical shift for letter A. None. There's no vertical shift. There's nothing being added onto the end. What's the amplitude? 1. So no vertical shift and an amplitude of 1. So that means my maximums can be positive 1 and my minimums can be negative 1. Vertical structure of the graph is done. Period. 2 pi divided by what? 1. 1 is the number in front of x. We get 2 pi. So just like we had there, we're going to mark off 2 pi. And I know that some of you will get tired of putting all these marks on there, but it is important. And just note that, like I said before, this is generally a really good test for people. Got a number of people come in and book to retake that past test, and they've improved their grade a lot. So if you want to retake that test, come and see me. I'd love to help you out. I like good grades. All right. So at this point, there is a horizontal shift. In order to determine the horizontal shift, I solve that equal to 0. X minus pi over 4 is equal to 0. What would we do to solve for x in that situation? Add pi over 4. So you get x is equal to pi over 4. Pi over 4 is the horizontal shift. I'm not going to show the horizontal shift yet. Before I do that, I'm going to make what we call a ghost graph. Every time there's a horizontal shift, I try to do a ghost graph ahead of time. I used to try to teach this without doing that, and students get really confused. I'll show you how to do it. Okay, let's just sketch sine. Where does it start? Max, min, or middle? Starts in the middle. And is this sine graph going to start by going up or going down? It's going to start by going up. I've reached the top. Now I come back down. And I carry through my pattern here. So this is not my real graph. This is what I'm calling a ghost graph. I'm going to use this graph to determine my real graph. So what I want to do is I want to create a horizontal shift of pi over 4. Can somebody tell me how much is pi over 4? Is pi over 4 this much? Is pi over 4 one tick mark? Is it the same as pi over 2? How would pi over 4 compare to pi over 2? Half of a tick mark, right? So I'm going to take these points and move them half of a tick mark to the right. So this point should actually be over here. This point should be over here. And I slowly move these points half of a tick mark to the right. And after you do that, you should come up with a sine graph, and it should be very apparent that it is the same graph, just shifted a little bit to the right. Question? So in this case, because we have parentheses, we had a horizontal shift of that much. This one, there were no parentheses, so there was no horizontal shift. So whenever you see these parentheses, you know you have a horizontal shift, and you're going to move it whatever that number says. We had to figure out how does pi over 4 compare to pi over 2. And if you think of your circle here, if this is pi over 2 up there and that's 0, pi over 4 was halfway. So we move it half of a tick mark. Half of a tick mark. We'll practice it. We'll practice it. Not always easy the first time. Okay. I think I want to turn to your worksheet. Let me see your worksheet. Yep, turn to your worksheet. Okay, so what we're going to do is we're going to do these first two problems for you. Question? Okay, let's try two problems together. Now, I'll be honest, this is going to take us a couple days, so tomorrow you're going to have time to work on this assignment in class, okay? And some of you guys haven't started your assignment from the other day yet. That needs to be caught up on too. So we're going to give you a little bit of time to do that after we begin with the checkpoint tomorrow. But these are pivotal, that if you can do these, you can get an A on the test. If you can't, the rest of the test can be a little bit disastrous. So let's see if we can figure it out. We start with the vertical shift. What's the vertical shift? 1. What is the amplitude? 2. Once I have those, I like to lay out the vertical structure of my graph. So if there's a vertical shift of 1, I put a mark at 1. I like to draw this imaginary line. If the amplitude is 2, how high will I go? I'll go all the way up to 3. How low will I go? -1. So you're going to go down 1, 2. You're going to go down to -1. Vertical structure of my graph is taken care of. Now we do the horizontal piece. How is it that I determine the period? 2 pi divided by 1 right there, and I get 2 pi. So mark off 2 pi, pi over 2, 3 pi over 2. If I solve that inside equal to 0, x minus pi over 4 is equal to 0, what do I do to solve for that? I get x is pi over 4. So there is a vertical shift, or a horizontal shift, right? Before I draw the horizontal shift, I'm going to draw a ghost graph first. I'm going to show what it looks like without the shift, because it's hard for people to picture how to do the shift without that. Sine starts at the max, min, or middle. Starts at the middle. And if it's positive sine, will it start by going up or going down? It's going to go up. So at this spot, I'm up here. Cross back over the middle. Down to the bottom. And back up. How much is pi over 4 compared to a tick mark? It's half of a tick mark. So I'm going to take each one of these and move them to the right. Half of a tick mark. All right, last one. Vertical shift. -2. Moves us down 2 units. What's the amplitude? 2. So this one's a little bit different than the others we've seen. Vertical shift is down this time. if the vertical shift is down 2 and the amplitude is 2, how low will I go? All the way down to -4, and you'll go up to 0. Oh, this guy? If there is a number on the end here, then it's not on the x-axis. Okay, so I have my maximum value of 0. I have my minimum value of -4. Because from this spot, I go up 2 and I go down 2. So I've got my vertical structure. Let's just do the horizontal part now. Period. 2 pi over 3. It's kind of gross, isn't it? So mark there, 2 pi over 3. What's half of 2 pi over 3? What's half of 2 pi? 1 pi. What's half of 2 pi over 3? 1 pi over 3, right? Take 2 pi over 3, divide half, you get 1 pi over 3. What's half of 1 pi over 3? Pi over 6. Let's look at how Devarian did that. He took pi over 3 and divided it by 2. What's the same thing as dividing by 2? Multiplying by a half. You see how when he multiplies by a half, see how he gets pi over 6? So we have pi over 6 right here. I want to get the third tick mark. How do I get the third tick mark if I know the first tick mark? Times by 3, and you get 3 pi over 6. What's 3 pi over 6? I'll write it down. 3 pi over 6 is the same as what? Pi over 2. So a little bit different how those divided up. We'll do the same thing on the other side. -2 pi over 3. Negative pi over 3. Negative pi over 6. Negative pi over 2. Good job. We're almost there. Is there a horizontal shift? Yep, because there's parentheses, there's going to be a horizontal shift. Okay? I should say that, like in this situation, there's not a horizontal shift. Even though you see the parentheses, there's no adding or subtracting that happens in there. It's when there's the adding and subtracting in the parentheses. So we take 3x plus pi and we set it equal to 0. How do I solve that? Subtract what? So I get 3x is equal to negative pi. Now what? Divide by 3, and I get x is equal to negative pi over 3. So there is a horizontal shift. We will show that graph here in a second. First, let's sketch our ghost graph. It's cosine. Does cosine start the max, min, or middle? Max or min. Why does this one start the minimum? Because it's negative. Okay? So we're going to start at the minimum right here. If I'm at the minimum, I go up. Then I get to the top. And then I come back down. Go through that same motion on the other side. So that's my ghost graph. It's not my actual graph. I'm just going to use it to get my real graph. Look at my shift. Negative pi over 3. If it's negative pi over 3, do you think I move to the right or to the left? How does pi over 3 compare to a tick mark? Is it the same as 1 tick mark? Is it the same as 2 tick marks? Is it half a tick mark? What is it? Yeah, it's 2 tick marks, isn't it? See how negative pi over 3 is 1, 2 tick marks away? So every point here has to move 2 tick marks that way. So like this point here moves 1, 2 tick marks back. This point here moves 1, 2 tick marks back. This point, 1, 2. One, two. Does it get confusing moving the tick marks after a while? Once you move them, you can stop looking at moving them and just start making the pattern. That's sometimes an easier way for people to approach it. Aiden, I like to be judged. Okay? Are you ready to judge me? No? Okay. All right. Tell me about my graph. Like on a scale of 1 to 10, what would you give me? Give me a 0. Okay, he's going to give me a 0. So I'm going to type it into the calculator, and I'm going to see how accurate my graph is, because sometimes people are like, that the graph probably looks nothing like that, like we just have a rough sketch. I want you to see if we're at all close to what the calculator would produce here. So I'll type it in, plus pi, parentheses, and I'll subtract 2. And I'm going to make sure I'm working in radians. We're working in radians when we graph these. And when I'm in my window, I'm going to set up my window so that my x minimum is negative 2 pi divided by 3. My maximum is positive 2 pi divided by 3. And I got a tick mark every pi over 6. Pi divided by 6. And my y max minimum is negative 4. My y minimum or maximum is positive 4. I got a tick mark every 1 unit. And we'll sketch the graph, see if it comes up. Kind of close? Yeah, I think it's pretty much spot on, isn't it? Could be better. When we make these graphs, it's really not just like a best guess or just a rough sketch. You're actually making very, very, very accurate graphs. And part of what I love about this is that this ties in what we've talked about for those who took math for college. First semester when we talked about vertical shift and horizontal shift. And when we flip stuff upside down, it connects those pieces together. So you are now set. These are 8 problems. You're going to start tomorrow with a checkpoint. We're going to do a couple problems together. You're going to be given time to work on this assignment. But you want to know this assignment, and you want to know it well. Okay? That's the secret to doing well in the next test. Because the next stuff we graph is not sine and cosine. The next stuff we graph is secant, cosecant, tangent, and cotangent. And if we don't know how to do these, we'll really struggle here a lot. But if we do know how to do these, then guess what? These are a piece of cake. Super easy. You'll be just fine. So go ahead. You got time to work on this and your other one. We're going to work tomorrow. Do a little checkpoint. Let me stop the video.